Okay, so for today's class, we have the past papers of circles, coordinate geometry. We have discussed all the theory we discussed in the last class. Many ways that the question can come in using the formulas of coordinate geometry, using the general equation of the circle, and using the circle properties. So we are going to continue and look at how the questions in the past papers are coming in. So in the first one, they are asking you find the equation of this. The equation of the circle is given to you: x square plus y square minus 8x plus 4y minus 5 is equals to 0. And then find the radius of the circle and the coordinates of C. C is the center. So we will have to just convert it into the general form. I told you how do you do this using completing the square form or any other method that you also have. So when you do that, you will get the equation of the center. So this would become x minus 4 whole square minus 16 plus y plus 2 whole square minus 4 minus 5 is equals to 0. So x minus 4 y plus 2, and this would become minus 25, which over there would go and become 25. So the radius is, you can see, square root of 25, which would be 5, and the center C is 4 comma minus 2. You take the opposite values. So you have got the first part easy, 3 marks. Then they have told you that the point 1 comma 2 lies on the circle. Show that the tangent of the show that the equation of the tangent of the circle is okay. So we have the circle, we have the center point 4 minus 2, and they have given you a point p 1 comma 2, any random point. They have told you that the equation of this tangent on this p value, they're asking you to find this. It is 4y is equals to 3x plus 5. We have to show this. So what we can do is, if we connect the center with this point p, this would be the radius, and we know that the radius and tangent, they are perpendicular. This is the property that we revised as well. Radius and tangent, they are perpendicular. So if you find the gradient of the radius y2 minus y1, so 2 minus minus 2 upon 1 minus 4, this would be 4 upon minus 3. This is the gradient of the radius, and therefore the gradient of the tangent would be negative reciprocal, 3 upon 4. Now you have the gradient, sorry, now you have the, yes, gradient of the tangent. So now y minus y1, the point is the p, the tangent is at p, so y minus 2 is equals to 3 upon 4 x minus 1, and we will simplify it and see if it forms this equation. So this 4 would go over there and multiply. So 4y minus 8, 3x minus 3. So 4y is equals to 3x, and this would become plus 5. Minus 8 would go over there and become plus 8. Plus 8 minus 3 would be plus 5. So you can see it is the same. Shown. So we have got the answer to the second part as well. Easy. Then the point Q is also on the circle, and PQ is parallel to the x-axis. Okay. Write the write down the coordinates of Q. So Q is another. This is your x-axis. We know x-axis would be a horizontal line. X-axis. Let's suppose. And there's another point Q such that PQ is parallel to x-axis. This means the Q point would be over here, because you can see now the PQ is parallel to the x-axis, horizontal. So we know the gradient of PQ will be 0 because it is a horizontal line. And we also know that the y coordinate will not change because it is horizontal. So y will be 2. We don't know the value of x. We don't know x. We know the value of y for the q because it is horizontally. It is in the same level as p. So this is how much? This is the y is 2. We don't know the x yet. So we will have to find that out. And how will we do that? How will we do that? We can do now. We know the equation of the PQ. It is y is equals to 2. So what can I do? I have the equation of the circle, x minus 4 whole square plus y plus 2 whole square is equal to 25, and I can substitute the value of y as 2 because I know I want to find the value of x when your y is 2. So one of the values of x I will get would be this one, and the other value of x, that's what we are trying to find, that is the BQ. So this would become x minus 4 whole square plus this would become 4 square 16 25. So x minus 4 whole square will be 9. So x minus 4 will be plus minus 3. So x will be plus 3 plus 4 and minus 3 plus 4. So you can see the other value of x is 7, and the one, this is your coordinate of P and this is your Q. On both of these, the value of y is equals to 2. So the coordinate of Q is 7 comma 2. This is your answer. Then the tangents to the circle at P and Q meet at T. So we will have to find the, this is the tangent on P, we can see that, and the tangent at Q will be like this, and they both are meeting at T. This is the point T. So we will have to find the equation of the tangent at Q as well. We already have the equation of tangent at P. We will find the equation of tangent at Q, this equation, and then we will simultaneously solve the two tangent and we will get the point of intersection. So if you connect the center with the C, the gradient of CQ, C is 4 minus 2 and Q is 7 2. So I can find the gradient between CQ. So 2 minus minus 2 upon 7 minus 3, 7 minus 4. So this will be 4 upon 3. And so the gradient of the tangent will be negative 3 upon 4. Right? So now we have the gradient of the tangent and the point of tangent C is Q. So y minus 2 negative 3 upon 4 x minus 7. I'm using the point Q. And now this will become 4y minus 8 minus 3x plus 21, 4y minus 3x, and this would become what? Minus 29 plus 29. This is the equation of the tangent at Q, and we already have the equation of the tangent at P. 4y is equals to 3x plus 5. So what would you do now? Simultaneously solve them, and the point of intersection will be the coordinate of T. 4 3 29, 4 minus 3 and 5. So y is 4.25 and x is 4. This is the coordinate of T. Okay. Any questions, anyone?
No, sir.
Sanchi, Ryan, do you get it?
Yeah.
Yes, sir.
Okay, take a screenshot of this one. This was a good question.